Welcome back, ladies and gentlemen, to session 3 of the FPSO World Congress Live 2020, day 2 on the 2nd of September. Right off the bat of the past sessions, we're going to listen to two representatives from ABB who will be talking a little bit more about gaining total ownership of FPSO project costs through digitalization in upstream operations. So Dave, I'd like to invite you to introduce the two speakers that we have.
Thanks very much, Jamie. Yeah, it's a good topic of great interest to all of us about digitalization, digital transformation. We're got some interesting things to hear. We've got two gentlemen, Jorg Thies, who's the Managing Director, Energy Industries Asia, ABB, will speak to us. He's the head of ABB's Energy Industries business line for Asia within the industrial automation business. He has over 20 years experience for ABB for the oil and gas and chemical industry, and he is a chemical engineer. Our second gentleman is Swarandeep Singh, who's the Vice President, Energy Industries Division, ABB. He's quite a industry expert and leader in large capital projects and looking into the systems, the processes, the technical side of things. A lot of good knowledge and experience he brings to us. And he's been in leadership positions in ABB Norway for several years. So I'd like to hand over to these gentlemen, if you could join us.
Hello, David, and thanks a lot for your introduction. We are very, very proud to be participants for this presentation. And based on all these ongoing challenges we all experienced during the last months, I can assure that is a lot of pressure and challenges we are getting. On the other side, we can also see now that the situation is becoming more and more a catalyst, especially when it comes to embracing the digital journey. Going for the slides, hopefully you recognize the same slides as I was showing last year. And it was last year a bit of positioning, okay, what is already possible today? What are the solutions we are having and where are we with the implementation? And you could see that a lot of companies are trying now to start with some digital ideas, starting with some topics. And the good part, what I see now in the market is more and more we are seeing some type of standardization, some type of common type of practice, like having a collaborative operations room, like have a same way of collecting data, using artificial intelligence, using some smart ways of bringing benefit out of the data and to really then improve the performance of the plant. Just two examples, MODEC for sure was even announced as a lighthouse project with one of the FPSOs by connecting 10,000 of assets then via a smart way. And they have definitely already realized 65% of downtime reduction just by using digital features. And that's very clearly a payback by using some of those new type of technologies. And another customer is Equinor, which is for sure also using digital to have a safe and sound operation to take care about the people, but also to check about, okay, how can the performance being achieved, starting from the feet of a project, starting from building a digital model of a plant already in a very early stage, using this digital model as the project execution will develop, and later on use it to train the operators, but also to check, okay, abnormal stages and to see with real data, okay, what critical situations can become into the plants. And all of those are definitely coming to the same conclusion using existing technologies we have today. Remote features using these collaborative operations rooms, using some instrumentation you have already in your plants can already start to predict at least 6 to 8 hours of a failure of an equipment. And if you are now starting to even install additional sensors, we are all seeing that we are even then able then to go beyond 24 hours of prediction then to see an abnormal stage in an equipment or see an abnormal stage in the process and to react accordingly. The good part between those type of elements is that we are really seeing that costs can be reduced. It really has an impact in the way we run our plants and to make them safer, secure, but also more efficient. It helps us to reduce the CO2, I think, which is also more and more a topic in today's discussion, especially when you are in the oil business. But on the other side, we also see now that the demanning or the reduced manning of the plants is coming more and more into play, because as more stable you're running your plants, as much less people you really need for interactions, as less people you need for continuous maintenance, when you only do maintenance when it's really required and needed. And we see now more feedback from our customers that also the amount of or the type of people we need on the sites has changed quite dramatically. So the good part is, especially now the challenges, especially the business challenges, have really been a super catalyst, embracing this type of elements, and also here especially availability of data, using those data with the new smart technologies, artificial intelligence, or cognitive computing. It's really helping to gain insights which you have not have before, and then really start predicting some type of problems. Our experience by just checking with our key customers is that if you really use digital technologies in a meaningful way, you can reduce CapEx and OpEx up to 30% roughly. And my colleague will later on give you a bit more about those details. But also projects can be completed nearly 25% faster than previously by doing it in a different way, embracing digital elements. And you have at least 40% fewer startup and installation hours. And I guess this is quite a huge impact, especially now when you see COVID-19. It's very hard to get people around, very hard to get people visa restrictions and those type of things. So digital is definitely one element which can really help us to address the challenges we are facing today. Going to the next example, remote. And we see more and more remote is becoming a new normal. I think I remember from last year's discussion that oil and gas, especially FPSO industry, is quite conservative. And I fully understand this, to really go for reliable and proven technology. But now especially, and this is a case we had to have in real life with a customer who has not digital in place, who has not really a good connection from his FPSO to the land site. He was calling us and he was having then a problem with one of his switch gears, which has started then to impact then his offloading and his water injection. And that could have definitely caused a loss of production for him. And based on the current regulations, we offered him to send an engineer, but it would take more than 2 weeks to have the engineer on the FPSO to help to fix the problem. And that's definitely something not acceptable for the customer. So we are starting then to say, okay, we have solutions, we have something available today. Are you willing to test it? And the customer was then starting, we call it remote insight. It's really using, I would say, limited bandwidth of communication. It's using some AI type of application. And we really have set up everything within 2 days. And now we were able then to use our experts from around the world together with an operator of a customer using then this VR goggles to really check the situation, to eliminate the root cause of the error, and then to fix it. So the plant was running, I guess, at least 3 hours after we have started the inspection with him together. And the lessons learned for him is, why should I pay any more for this type of travel cost? Why should I pay for this experts when I just need him this few hours, and when I can do it definitely with my existing maintenance crew with the support of these new features and new technologies? So that was one of, I would say, the most obvious learnings for him. But the second one was also, he was always cautious on the data side, cautious on how we get the connection right. And it was rather simple, and it cost us just a few tests to really have a quite stable connection with the right bandwidth where the data could be exchanged between our collaboration center and his sites. So even those you are hesitant, I think just this real life example has shown that this remote works well. It brings a lot of benefit and it's much easier to implement. And now especially the customer was so much in the demand that he was probably coming out of his comfort zone and testing something he was not keen to test it before. But the impact overall has paid it. He has now bought already 3 of those VR goggles from us, and he is completely now into it because he has really made his own calculation and he can now see that he can do a lot of things in the future without using those experts, without letting them come to the site, and then just pay per use. And that's probably one of the nice features as well for him. So remote is definitely something we can use. Another use case, what we are seeing more and more are virtual AVTs. Customers are not able then to go to our staging rooms. Travel is becoming more and more an issue. And you are losing also quite some time and efficiency during those travel times. And we have seen that those virtual AVTs is becoming something customers are very likely to embrace, very likely to do it together with us, where we are using those type of equipment to show him what's going on, to show him the tests without his people need to be on site with us. The only thing, and that's definitely a limitation still today, inspection can of course not be done like this. You really need to have a physical person in place for inspections. But a lot of things, especially during those FATs, can be done now by remote. And I believe that the payback, the efficiency increase is definitely worth taking a look into this one. Coming to the next model, and this is a case study with OKEA. The plant is rather old, from the 90s, so digital not really very well connected. And customer is facing, of course, some obsolescence problems. And the key topic on this one here is that we're really trying then to have a collaboration in place with a customer to say, okay, how we can make those things happen. And one of the key elements here was that we are really dealing with raw data. So we are not consolidating data and then sending the concentrated set of data to the specialists. We are really now having an edge solution together with the customer, and we can send raw data within milliseconds to the collaboration center, and the customer is able now with the raw data get much better insights, gets much better topics from it, than having some consolidated data which you normally get from a historian application which is running on the site. Everything interesting message here also was it was not as complicated as we thought. We can send from at least 10,000 texts raw data within milliseconds to the site. It's 180 kilometers from shore, so quite a distance already. And you're seeing by having the raw data, experts are able then to predict much better, use much better those mathematical instruments to really derive some key insights. And again, you don't need to be on the site. You can do it from remote. And here also, one thing is coming also, as more data you have, as more detailed data you have, as much better the prediction will become. And this is on top, of course, that is always now a collaboration between the one who is providing the data, but also the subject matter expert, because as you need an expert still to analyze the data and to derive the right insights, which is coming out of the data. I like these examples very much because we have really also said that the complete burden on developing this type of application, on creating this was on our side. So we have delivered this as a so-called software as a service application to the customer. And we are now providing the customer his raw data in the right amount in a very safe and secure manner. And he is now using it and he really sees the benefit of this type of application. And even the plant is a rather old one. It has already paid off within a rather short time because he can now run some of his equipment much longer than anticipated before, and he can start optimizing his plant without making too much modifications then on his side. So quite another case where really this collaboration between a customer and us has really worked out in a nice way. Coming to a topic, we are all seeing now the market is becoming more unpredictable. think the oil price was nearly turning into the red zone. A lot of challenges going on in the market. It's becoming faster where we have to react. And for sure, all of this is definitely leading to the fact that we have to see, okay, how can we do things smarter? How we can do things in a different way? And important here is also how we can be more efficient. And I know that oil and gas is very strong on own type of standards, on own type of data models, and not sharing information between even companies itself, and rather not outside companies. And of course, not following any type of standards. But seeing how the market is going, seeing all the trends and the pressure which is coming, we definitely have to start embracing some of the existing knowledge and technologies which are valid in other industries. I think automotive, for sure, one of the trendsetter on how to do things in the most possible efficient way, how to embrace those elements. And even if we don't jump to those type of elements, it's definitely worthwhile now looking into the details and say, okay, what is it what we are able to do? And on this slide, you see probably some elements which only can be done already on the engineering side. I know we always think immediately engineering, you think about tools, and you think probably about low-cost engineering. But what we have realized when we really go into the details, there are much more levers and elements you have to consider if you really want to become much more efficient. And one aspect which was really interesting for me was that the human aspect is the one we probably tend to neglect. It's about the competency, about the right people. And by considering all of those elements, what we have seen is you are able to reduce nearly 30% of your engineering cost. 30% of the total engineering hours can be reduced if you really go after all those various elements and you really start optimizing them, thinking about having a standard in place, thinking about the methods you're using, how you define the task, how you split the task, how you derive elements. And I would say this is something worthwhile looking deeper into it. And with this, I want to hand over to my colleague who gives you a much more detailed input about the project execution and how elements we are using generally can help you to execute projects in an efficient way.
Yeah, thanks, Jörg. And I think you have put up a few keywords which pretty much sum up the whole scenario here. You mentioned standardization, you mentioned data, and most importantly, you mentioned people. And from that perspective, I think people do projects, and the industry knows us as a large supplier of automation equipment, as supplier of electrical equipment, motors and drives, but we are also a very, very large project execution organization, always in pursuit of relentless execution. And some of the figures that Jörg has talked about earlier, reducing capex, improving schedules, reducing engineering hours. Those are the things that we have learned over the years, executing large capital projects, using the levers, some of the levers, the processes, the technologies, and the people, whereby we are using different methodologies to actually reach these figures, and make sure that we live to our promises. If you go to the next slide, Jörg. So, what we have been seeing in the past is, before COVID, labor arbitrage was the thing. Most of the companies were leveraging their low-cost centers and then trying to improve the cost and reduce the capex and the risk. And as we know, I mean, COVID has been a great disruptor here in the way we are going to work. Remote abilities to work remotely, abilities to include more automation. I think it acts as a catalyst, as was mentioned earlier, and then it allows us to use some of the modern technologies which we have at our hand and which we have been using for some years, but not as a common practice. So we are using virtualization, we are using decoupling the hardware from the software, making the execution more predictable, bringing in a lot of standardization into our execution models, bringing in a lot of standardization with respect to the solutions that we apply, a lot of reuse capabilities, which are allowed by the use of modern automation technologies. And all that sums up to the kind of promises that we have made earlier. And all this is made possible because more and more customers are now being forced into this situation where they're embracing these kind of hyper automation, if I can use that word, so as to make sure that they are able to reduce their capex in case of large capital projects. If you go to the next slide, Jörg. So more recently, we have a couple of examples here. We have a project, Johan Castberg, that's an FPSO in Norway being built currently in an FAT stage for Equinor. And here we are using the remote FAT capabilities that we have developed. We have used some of the modern technologies inside the project execution, and we have used stuff like decoupling the hardware from the software, a more data-driven approach to execution rather than based on documents. So we have created interfaces, we have created these APIs and tools whereby we can import data from the various engineering contractors into our internal engineering systems and reduce manual work, which then improves the cost, it improves the quality, and then you have less errors at site, which allows you to start up on time, start up in a more flawless fashion. Another example, this FPSO and Aneri, this is a recent project, and here again we are going to employ all these modern technologies to make sure that we meet the expected budget targets for our customers. If you go to the next slide, Jörg. So what we see is we started off with this transactional approach of having these point solutions. We have tasks, different tools, different methods related to agile and lean, all these leading up to how we can make the projects more cost effective, how we can deliver on time, and how we can reduce risk. And those are more kind of a tactical and transactional tools that we have at our hand. But the industry is also now going towards a more strategic approach whereby we are getting into a different kind of contracting model, which allows us to actually improve the way we work together. It improves the collaboration. So we have less interactions, less conflicts, and less interfaces. And we have also have such kind of experiences with some projects around the globe, specifically with ABB in Norway. For some of their projects, they have already got into this alliancing kind of an agreement whereby it's a win-win for all the contracting partners. So I think the industry is definitely in a transformative mood now, which is being catalyzed by the COVID disruption. And we would definitely see that the tools and methods and the efficiencies that we have developed over the years, we are able to synchronize them and apply them to the upcoming projects, thereby improving the costs and also improving the efficiencies, and they're delivering on time and on budget to our customers. Yeah, so that was a quick view on some of the project execution aspects which we are working on currently, and also where the industry is leading into. So I think we can field some questions if there are.
Yeah, that's great, Jörg and Swarandeep. I liked how you mentioned the people element. They like to quote that something like 70 or 80% of digital transformation pilot projects fail because people don't take account of the people element.
Correct.
They still have the same sort of decision hierarchies. They don't use agile teams. They don't change workflows. How do you work with customers to change how they're changing these kind of work culture and and workflows? Do you give them advice? How do you help the customer?
I think that's a very good discussion, because we have exactly experienced this in an example where we had to have a ready solution, and the solution was really working and was in place, and then the customer was still working as never was getting done before. And then when we started discussing it, then they started realizing how important it is to really have this type of, I would say, change management. And in ABB, we have even a few guys which are doing nothing else than really having this type of discussions with a customer to really say, okay, by using this type of solution, this is what you can really start of having as a financial benefit. But it also means that we have to redefine the amount of processes, the amount how you work, even the setup with your people. And interestingly, in a very large project we are undergoing, one key element was that we also have quite some consultants working together with a customer to really design what is the organizational setup, what is the type of skills and trainings that people need, because we need different type of people, different type of activities than we had have before, and then use this then in the most efficient way. And it's an element we should not underestimate. It's not just about installing some software and then you think you're done. It's really all about having the 360 degree, that you really have to consider those various type of elements. And again, we are there, we are seeing this now in real life. We have people addressing it, but it requires also a lot of things inside the companies, because you can imagine it's not easy to change the setup of some organizations, probably to lay off some people, or to then have those type of training sessions with your persons then.
I can add to what Jörg said. I mean, this is the soft side of the projects, David. People do projects, so we need to have people who are having this collaborative mindset. Some of these large capital projects are running for years. You know, these are not just 12-month, 18-month endeavors. They are running for years, and so the key here is developing these high performance teams much earlier in the project phase, so that you are able to, you know, address some of the challenges that you have mentioned. And that is one of the reasons why we as a project organization, we would like to engage early with the customer to understand their pain points, and then you address those which are related to people and culture much earlier in the project phase.
Yeah, that's good. I also like the idea of bringing in the operational people early.
Yeah. Correct.
This isn't just something that gets thrown across the wall at the end of the project execution, that they come in early to, they help the designers, and I suppose things like operational training simulators, your systems feed from the project into those kind of systems, is that right?
Yes. So we have very successfully used these OTSs, and we have different use cases. You know, of course, you mentioned training, which is very important, especially if you are, you know, building up a project in a new country. You need trained operators, and then OTS is a very useful tool for that. And in addition to that, we also very successfully use the OTS systems for validating and testing our applications. So you can actually create a model, a digital twin of the plant, including the process, and then test all the application logic, all the HMIs, you know, the whole system, even before the process is built, even before you have, you know, laid the foundation stone. So this is a very, very unique tool which improves a lot of efficiencies in the execution phase.
So you've got this really nice project execution story. You have this cloud platform. You've got all your information in there. We want to carry this on for the life cycle. We want the operations guys. We want the subsurface guys to get involved. How do you make sure this cloud platform carries on into the operation phase?
I think that's a very good topic. And interestingly, we have for quite a lot of customers, we are keeping this cloud information online for them. So we are hosting all the project related informations for the customer. And even some of the customers have then decided if they are doing some changes in their sites, they are coming to the ABB office. They have a special room dedicated to the customer and they do the changes there. They test the changes together with us. They update everything what they do first and test it. And then they go back to their sites. And we see that this model is bringing a lot of efficiency because on the one side, the customer is doing things on himself, which is making him much more knowledgeable and confident with the system and application. On the other side, by us keeping always every change with our cloud software with it, we can test every software change, every software upgrade already on this system before we going out in the real plant. And then we can avoid a lot of possible obstacles and issues then later on.
Okay.
And on the so that is one model. The other model is where we could deliver the OTS to the customer. So they have it. They have this digital twin in their plant, and so they can use that as a management of change function, or they can use it to validate and test the later on changes which they are making at site. So it's a kind of a life cycle approach to the whole project execution.
Okay, good. We have a question from the audience. I would like to know when you consider it appropriate to place the AI sensors in the equipment during the final manufacturing phase, during the final assembly phase, or during the conditioning tests. I presume he's talking about edge sensors and edge analytics and things like that. How do you work with this kind of tool?
I think I give you an example from a chemical customer, and I was quite interesting with him. His first discussion before he was really starting about building his plant was really starting about the network, the way of network for getting all this additional data connected, how to design the network so that you even when starting building the plants, you can even start now using smart things to track the workers, to see which workers are working where, what they are doing, how to track those type of elements. And then slowly starting already using the equipment together with those sensors. And what we also know from the past is you have either two elements when you have some issues with equipment, and mostly it's in the startup phase. So having equipment already equipped with some sensors in the startup can help you to see if something is going wrong in the wrong direction. And give you here the example, we have seen some common pattern on some pumps when we got a brand new or overhauled pump and we just checked it with a sensor and we could immediately say this pump is not working properly. So you can even use now some of those sensors as a quality aspect to check every equipment you have before you really build it in, before you really have everything done, if this equipment is really behaving in the right way when it comes to vibration, noise, and temperature, and use this as a quality element. And it also saves a lot of things that you don't have to exchange them later on just doing commissioning or doing startup.
Yeah, I like that idea. You know, the idea that you could have an FPSO sitting in Singapore being constructed, topside modules being installed, and at the same time, go ahead and fire up the satellite communication system, have the engineers who might be sitting on the other side of the world in Norway be able to see some of the data. So as things are pre-commissioned and everything, like you say, sometimes things will, if they're going to fail, sometimes they fail right away. The sooner we can detect that and sort it out, the less impact we have on the overall project schedule. So I like you have that ability.
Yeah.
You mentioned at the beginning about the virtual reality, the augmented reality. I think people say that's one of the most important uses of that technology is to help the field maintenance. How did that actually work in the field then? The guy had the headset on and everything. Does he walk around the deck of the FPSO? How do you communicate with him when he's on the deck of the FPSO?
I think you for sure have, when he has those type of equipment, you should still have also a communication a phone or a radio then with him, so that you can guide him. So you rather use sometimes the person like a robot manipulator than to do whatever you tell him. The good part with those type of augmented is you should not do it in freestyle. What we have realized is it's also a bit about following a certain type of checklist, following a certain type of how you do it. So we discuss normally before someone does the task, we discuss the task with him so that he exactly knows what we are going to do together with him, what we are going then to check it with him. And the part now is what those type of applications have. You can also give them those checklists so that he can visualize those things when he's really starting to go there. And then you really start doing it, because one of the elements is if you're not familiar with high voltage and then all of a sudden you want someone to go in there, it's quite important that all health and safety related elements are very properly considered. So having a very good process definition, have a very good preparation in place is very key. And then you can also make the best use out of those type of classes. It's not just take the classes on and let someone go around and then you get the right value out of it. It requires a little bit of a guidance, a little bit of a way how you do it to really have then the right benefit right away. Interestingly, having those classes and working with the person, it's quite a nice interaction, because he can see things, he can smell things, he can hear things. You don't get it directly over this one, and you are still required, and that he's also giving you those type of additional information you probably would not just see then out by looking then through those cameras.
Yeah,
so you need to get some
powerful
training, and it has to be planned before you let somebody use it. So David, if you want to give it a shot in your office, that is quite different to when you are doing it on the platform.
Oh yeah, we can't distract the guy either. So he's got to safely move in and out and everything. So he might have a little voice in his ear and a little camera watching what he's doing, but the guy's got to be safe. So having communication systems out on the deck of an FPSO, Wi-Fi communications around the deck, maybe 5G, what kind of communication tools are available around the deck of an FPSO back to the control room, back up into the cloud to the remote office? Is that something you guys work with?
Yeah, we do work with some of these technologies, and for sure 5G is something which is rapidly evolving, and we are really looking into it with the different use cases that would evolve eventually, and then having the necessary products, the base stations and the rest of the infrastructure in place so that we are able to exploit it. But traditionally, you have SATCOMs and the rest of the traditional communication technologies available, which we use for the purpose of employing various tools and methods, including this augmented field procedures or these augmented reality glasses.
Okay, well, I think that's just about all the time we have. I want to thank you for a very timely presentation, a lot of good tools and technologies and workflows for us to use. And thank you for sharing all that with us.
All right.
Thank you for having us. Yeah, thank you, David. Thank you, Jamie.
Thank you, Dave. Thank you, York. Thank you, Sorandip, for a very interesting session. Now, coming up next, we have a virtual speed networking session happening at 6:10 p.m. Singapore time. But before that, here are two videos from ABB and Rambling.
Hi, I'm Ramesh Maradana, Technical Manager for Electrification and Power Management System for Energy Industry Division within Hub Asia. Today, I'm going to talk to you about ABB Process Power Simulator, which is also known as PPSim, PPSIM is a high-fidelity electrical network simulator which provides a realistic experience to your operators and help them to learn on how to avoid power blackouts, perform a black start, perform shutdown operations securely, and handle different critical scenarios effectively. ABB Process Power Simulator has a unique function and goes beyond what a process model vendor typically provides, as it combines a copy of electrical plant control system along with simulated electrical dynamics to provide operator with more live-like experience. Integrating with control system provides a digital twin for your operations. In other words, it's a safe way to train your operator to learn the system which they rely on real-life scenarios. Process Power Simulator has two parts, which are topology editor to build an electrical model, and secondly, instructor workplace to simulate different electrical scenarios. Let us take a look at how to demonstrate building an electrical network using topology editor. ABB Process Power Simulator makes it easy to create an electrical model with a single line diagram. Through a topology editor, you can build your own electrical model by dragging components here and connecting it to electrical network. You can also set a basic and advanced parameter setting of the equipment to replicate your plant behavior and then save the model. Next, you can switch to instructor workplace to simulate plant electrical dynamics for different scenarios. Here in instructor workplace, we can create different scenarios by selecting and controlling motor, circuit breakers, generators. ABB Process Power Simulator dynamically models frequency, voltage, active power and reactive power according to the equipment characteristics and generator response you define in topology editor. To test electrical dynamics, we will run through the scenarios which are most frequent in FPSO operations. Let's begin with starting a generator. To start a generator, click on the generator, make sure it is in local and press on start button. Once you start, generator builds up its voltage and frequency like you see in the screen. Once it reaches rated voltage and frequency, we can close the breaker A15 to connect this generator to network. To close the breaker in A15, we have to go through a synchronization process. To synchronize the A15 to the network, select on sync module, select the breaker we want to close, select the generators we want to synchronize, then click on synchronization module. Start synchronization. Once you press start, synchronization process starts, like increasing, decreasing of frequency with respect to variable and reference. Once it matches, it closes the circuit breaker. Now you can see all the three generators are connected to a network. So the next topic, once we have the three generators in the network, to share the load among them. To initiate the load sharing with the existing generators, we have to give control to remote. Once we give control to remote, remote operator will select the mode of operation. In this case, it is P control and Q control, so that they can equally share the loads in the network. So once the operator sets in P and Q control, new generator starts picking up the load and the existing generator start releasing the loads. Here you can see the trend. The existing generator 1 and 3 are releasing its load and the second generator is picking up its load. And this goes on till they are all equally shared. And then we can control this equal share, unequal share in the remote control system by selecting equal and unequal control. Now you can see all the generators are reached to a level of equal loading in the network. Now once all the three generators are stabilized and sharing the loads equally, let us simulate a scenario of starting a DOL motor and verify the generator response. To start a DOL motor, click on this breaker and click on start. Once you start the motor, you can see the response at the starting kick of motor in the HMI. You can see a sharp rise and then later settle. Now let us see how our generators will respond to starting of a VFD motor. To start a VFD motor, click on a VFD, select start, and you can see the response of the generator. It's a smooth ramp. It's not a kick, it's a smooth ramp. After that, we want to test a malfunction of a generator, which will lead to a blockout in a normal scenario. But using ABB Process Power Manager, the intention is to avoid such blockouts. So let us simulate a malfunction in network and see how control system responds to it. To initiate a malfunction, click on the generator, go to malfunction tab and click on malfunction. Now you see once you click on malfunction, it triggered for a load shedding. Once the load shedding is triggered, the transient window will pop up where it records the transients of the network, voltage and frequency. You can see a dip in a voltage and frequency and corrected back by other two generators working in the network to a system voltage. Okay. With all relevant information at your fingertips, it's easy to tune protection settings, generator parameter, and load shedding priorities. ABB Process Power Simulator provides a realistic way to new operator to familiarize themselves with your system and learn to respond to a critical scenario or a malfunction in a safe manner. Having a digital twin of your actual system, you can simulate your plant operations for the whole life cycle, that is from design to start of production, and helps you to optimize operational performance. For more details, please visit abb.com or contact your nearest ABB sales representatives.
REMBY, safety is for life. REMBY in Brilon, Germany has been manufacturing top-quality rupture discs and pressure relief systems since 1973. Thanks to its wide range of specialized relief solutions for safe and sustainable service, REMBY has become a world-renowned player in the process industry. Friedhelm Kesting has been leading REMBY's production facilities since the very beginning. My name is Friedhelm Kesting, and I've been with REMBY for over 42 years. Purchasing the first laser welding equipment at the beginning of the 80s was certainly a milestone in the company's history. REMBY has been a user of laser technologies from the very beginning. As well as having customers in the chemical, petrochemical and pharmaceutical industries, REMBY works with large EPCs and shipyards around the world on important FPSO projects.
I have been personally working on FPSO projects for REMBY since around 2005. Pressure relief is required for many different parts of the production processes on FPSOs. Working on the FPSO projects is perhaps the only time we are asked to supply so many different disk types at the same time to protect all the individual processes.
Rupture discs are used on a range of FPSO applications due to their rapid full-bore relief, reliable burst control and compatibility with other pressure relief solutions. Complying with critical material specifications, REMBY's rupture discs are available in a wide range of advanced and highly corrosion-resistant materials, while complying with NACE and NORSOK standards when required. Each FPSO project contains many different types of rupture disc. Now let's have a look at the oil and gas separation. The oil and gas separation and treatment process is a safety-critical application using pressurized vessels which require pressure relief protection to ensure safe operation. Rupture discs are frequently used in combination with a safety relief valve as a secondary relief device. Ramby's masterpiece is the unique KUB rupture disc with incorporated laser-cut buckling elements that allow exact burst pressures and maximum lifetime of the device. Continuous quality checks and burst tests prove the impeccable performance of the KUB. The KUB is used in all kinds of industries, in gas or liquid services, and has proven its performance in thousands of applications over the last 30 years. The two-layer construction ensures robust handling, a very high operating ratio, and a torque-independent installation of this rupture disc. The KUB provides full bore opening upon burst. The sealing membrane has wrapped around the buckling pin element, and fragmentation-free opening is guaranteed. And here are the gas compressor module and the heat exchangers. Rupture discs installed on a gas compressor module are designed to protect the tubes on a heat exchanger from exploding due to overpressure. Rupture discs are used due to their speed of response. Ramby's IKB is such a high-speed disc. Its single-layered reverse-acting design has specifically been developed for projects such as FPSOs. The peripheral opening pattern provides full bore opening, and the style of the disc ensures a very high operating ratio and a good opening behavior for this type of rupture disc. And finally, we have the flare stack. Protection of the flare system is critical. In the event of overpressure, the activated rupture disc will safely vent the pressure to re-establish the path to the flare, which is ignited to burn off the unnecessary gas. Ramby's double disc assemblies can either be a combination of two forward, two reverse acting, or a combination of rupture disc types dependent on the particular process conditions. The primary function of the assembly is to protect the primary disc from variable back pressure. The perfect disc for flare stack protection is the SFD. The SFD is a single-layered forward-acting disc. The paddle-shaped burst elements provide an exceptionally good pressure cycle resistance and perfect opening behavior. All made possible by the Ramby exclusive CPL technology, Contour Precision Lasering. Thanks to Ramby's own CPL technology, we supply high-performance bursting discs for cost-effective and reliable solutions for our customers. Ramby discs can be used in combination with signaling devices such as the reusable non-invasive NEMU for signaling of the disc's function. The NEMU sensor is mounted in the outlet of the holder without direct contact to the process. Once the disc opens, this breaks the circuit within the NEMU sensor and sends a signal that the disc has activated. Once installed, the NEMU does not need to be replaced after the disc has burst. Ramby's work within the FPSO industry doesn't end with product design. In line with their policy of consulting, engineering, products and service, Ramby's engineers are available to support with troubleshooting, installation issues, as well as difficult design challenges. Dr. Stefan Rüsenberg, Chief Technology Officer at Ramby, has a typical case study for you where Ramby engineering saved both money and space for a tricky heat exchanger application.
An engineering company from the oil and gas industry asked for support to improve their safety concept to protect the heat exchanger. A multi-phase flow has to be relieved into a flare system with variable back pressure protected by a 10-inch relieving device. By some well-engineered improvements, our safety concept is providing a 4-inch double disc design relieving into a 4-inch relieving pipe. The upstream disk is protecting the heat exchanger against excessive overpressure, and the downstream disk is isolating and protecting the first disk against the variable backpressure. This leads to a robust and practical solution which saves space and reduces costs of the relief device as well as the discharge release system.
From a wide range of safety products to the engineering of turnkey solutions, Remby is your perfect partner for pressure relief in the FPSO industry. And if an overpressure event results in a stop in production, the Remby Rush Order service is available to manufacture replacement rupture discs within 24 hours to get production back up and running as soon as possible. Whether laser welding or laser cutting, laser systems are still at the very heart of our production and have guaranteed the reliability of the unique Remby rupture discs for over 30 years. Remby, safety is for life. That is our promise to our customers.
Okay, ladies and gentlemen, I hope you have enjoyed the 2 videos we have prepared for you. Now, I understand that some of you have had issues with the speed networking session yesterday, so do take note of the following points to ensure you are able to make full use of your time with us today. What you need to do first and foremost is to quit this Zoom application completely or any application that is currently accessing your video and microphone. This will affect the speed networking session on this platform. Next, after you've done that, go back to the agenda timeline and repeat the same process. Firstly, join the virtual speed networking session, join the conversation, and you will then be brought into a meeting hub with 2 other participants. So this is what you need to do. At 6:10 p.m. Singapore time, click on join. Once you've clicked on that, you'll be brought into a page that allows you to join the conversation. Once you've done so, you'll be able to meet 2 other participants in a 5-minute networking session. So all you need to do is to exchange 4 points, mainly who are you, where are you from, what do you do, and most importantly, why are you here? At the end of the 5 minutes, click join another conversation and you will be brought into another networking round. There are a total of 5 rounds, so you'll be able to meet a lot of different people and make new friends throughout this Congress. Now, I hope all of you will be able to hop off this Zoom session. Once again, a gentle reminder to quit any Zoom application or any application that's currently accessing your video or microphone, so you'll be able to make full use of the virtual speed networking session that we have for you. Thank you, and we will see you there.